Distinguished guests, ladies and gentlemen, welcome to IP Club Carnival 2021. IP Club is initiated by Huawei, and we are committed to building an open, cooperative, and sharing platform towards IP industry opinion leaders. At IP Club, you will be joined by the best minds in the industry, including network technology experts from around the world, to engage in thought-provoking conversations about future network development trends, explore new opportunities, share perspectives on digital transformation, and chart the way forward. It is the fourth year that we hold our IP Club Carnival global event today, and we are honored to invite industry technology leaders, professional analysts, and technical experts to exchange thought-provoking ideas on intelligent IP. With deepening enterprise cloudification and digital transformation, IP networks need to carry an increasing number of key services. This trend gives rise to many new network challenges. So how can these network challenges be addressed? A viable method involves digitally and intelligently upgrading IP networks with technological innovations. First of all, I would like to invite Robin Lee, Huawei Chief Protocol Expert and IETF Internet Architecture Board Member, to give our keynote speech entitled Insights into Huawei Intelligent IP Technology Architecture. Please give him a warm welcome.
Hello everyone, this is Zhenbin from Huawei. You can call my English name Robin. I'm the Chief Protocol Experts from Data Communication product line. I also take the position of Internet Architecture Board Member in IETF. Today, the topic of my presentation is Insight into Huawei Intelligent IP Technology Architecture. We know that this is a very important development trend that is fast industry digitalization. As the development of the 5G, VR and AR, cloud, and artificial intelligence, these new services also propose the new challenges to the IP network. These challenges including how can network deliver desired bandwidth, how can network ensure service experience, and how can network achieve and improve operation and maintenance experience. The new development trends drive the IP technologies into a new era. We call it as the intelligent IP era. In history, there are different characteristics for the different time with the IP technology development. We summarize that in 1990s, that is the Internet IP era. That means IP used for the Internet. From the early of the 2000, we enter into the all IP network. That is the telecommunication network. Technologies are replaced by IP technologies. Now, with the development of 5G and the cloud, we drive the IP technologies to support the pervasive intelligence. We call it as the intelligent IP era. In order to be aligned with the new IP era, that is to support the development of the intelligent IP development, Huawei set up the intelligent IP strategy. The Huawei intelligent IP strategy can be summarized as 1, 2, 3, 4 plus X. This means 1 means we have the one strategy, that is intelligent IP strategy. 2 means 2 platform, that is Huawei developed the new platform, including the new software platform and the new hardware platform. 3 means 3-layer intelligent IP network architecture. The 3-layer IP network architecture including super capacity for the physical layer and intelligent experience for the network link layer and autonomous driving for the network control layer. Next is the 4. 4 means 4 engine. Huawei has end-to-end data communication product and end-to-end IP network solutions. We summarized as the 4 engine, including Air Engine for the wireless, Cloud Engine for the data center network, and Net Engine for the IP1 network, and high-sec engine for the security. So based on this, the 1 strategy, 2 platform, 3-layer IP network architecture, and 4 intelligent IP network engine, we can enable all kinds of industry to enter into the new intelligence era. So we call it as X. X means all kinds of industry. Okay, Huawei also set up the end-to-end intelligent IP network solutions. These end-to-end IP network solutions can be divided into the campus network solutions, and this is the WAN network solutions, and also the data center network solutions. So for the campus network, we can depend on the unique smart antennas technologies to achieve the super capacity. And we can also depend on the WLAN intelligent radio calibration to implement the flexible and intelligence adjustment for the service. And also in the campus network, we can support the AI-powered intelligent operation and maintenance solution to simplify the network service provision and network maintenance. For the WAN network solutions, now we can support the FlexE-based slicing technologies for exclusive bandwidth assurance. We also support the SD-WAN solutions to implement application-level intelligent traffic steering and optimization. And also for the WAN network, depending on IPv6 plus technologies, we can implement fast network change with the cloud. And also we can implement intent-driven intelligent traffic steering. For the data center network, we can support the 768 multiply 400 gigabit purchases. So this can support the huge capacity for the data center network. And we can also support the industry-first intelligent lossless data center network. That means we, through the intelligent lossless technologies, we can reduce the packet loss in the data center network. So this can achieve the high computing power. And also in the data center work, we also implemented the 1, 3, 5 experience for the network operation and maintenance. That means we take 1 minute to find the issue in the network. We take 3 minutes to find the root cause for the failure. And we take the 5 minutes to restore the service. Next, we will take the 4 key technologies, and we will introduce a little details about these 4 key technologies. which can support the intelligent IP network strategy. The first one, that is the SRv6 technologies to implement the one hop to connect cloud. So that's in the past years, MPLS plays an important role in the IP network and implement the all IP network. But as the network development to support the cloud services, it's needed to span multiple networks to connect the service in the cloud. But this is difficult achieved by the MPLS technologies, because for the MPLS, it always implements the MPLS islands, but it has to connect different MPLS network islands. So based on this, the SRv6 technologies, we can achieve the connections crossing multiple network domains, because all network can support the IP connectivity. SRv6 is compatible with the IPv6 technologies. That means SRv6 can take use of the IPv6 connectivity, can cross the multiple network domain and enter into the cloud for the different services. So Huawei, until now, are leading the technologies of the SRv6 standards, and Huawei also support almost 50 deployment of the SRv6. Next one, the important technology is network slicing. Because in the traditional IP network, in order to isolate different services, we have to set up the dedicated networks for the different services. The cost is very high, and the network management and maintenance is very complex. But with the network slicing technologies, we can implement multiple network slices in one IP network. For each service, there's an isolated network service. And also Huawei can support the FlexE technologies. We can implement the hard isolation to guarantee the SLA requirement for the different service very well. So network slicing and the FlexE advanced hardware technologies can implement one fiber for multiple users. One network can transport multiple services. Next technology is AI-based operation and maintenance, because we know that as the development of the cloud service and the IoT, there's many connections, and all kinds of things are connected through the IP network. So this proposes this challenge to the network maintenance and operations. In order to simplify the network operation and maintenance, we can support the 3-layer AI architecture to deliver proactive operation and maintenance. That means the equipment can support the AI based on the embedded AI chip. And we can also implement the network AI and also this cloud AI. So through these 3-layer AI architectures, we can collect the huge network data. And according to this data, we first to do the analysis based on the original network data. According to the analyzed data, we can abstract characteristics. And according to the abstracted characteristics, we can identify the abnormality in the IP network. Through this, the AI-based operation and the maintenance technologies, we can simplify the network service provisioning and troubleshooting. The fourth key technology is security. Huawei can implement lightweight security deployment in the device side, and Huawei can also support Qiankun Security Cloud Service Platform in the cloud side. So through the device cloud synergy, encrypted transmission, and cloud-based security capacities, Huawei can implement end-to-end cloud network security solutions. And also, based on the AI technologies, Huawei security solutions can implement threat detection accuracy up to 99%. According to this, the Huawei intelligent IP technologies and also the intelligent IP tech strategy, Huawei try to implement vision for the datacom industry, connect everything with pervasive intelligence. So the slogan for our innovation is IP on everything. That is, Huawei IP network in the new era will connect the computing power to all over the world and to everything. And in the past, Huawei developed the new software and hardware continuous and achieved a lot of new achievement in the industry. This innovation, including the super capacity through the line card and the optical module, and also we support the architecture from the SDN to the intent-based network to now autonomous drive network. And also through this, the campus insight, fabric insight, and this the net insight, we can achieve this the intelligence for the network. Huawei also leads the standards in the industry. Huawei joins 12 plus industry standard organizations and take more than 40 working group chairs or higher positions in these industries. And now Huawei also can support 400 and more IETF RFCs. So Huawei depends on the three-layer intelligent IP network architecture, super capacity, intelligent experience, and not autonomous driving. And also Huawei depends on the four network engine, such as Air Engine, Cloud Engine, Net Engine, and high-sec engine. Now, Huawei is leading intelligent IP networks. That's all my introduction about insight into Huawei intelligent IP network architecture. Thanks, everyone.
Thank you, Robin, for your wonderful speech. In the digital world, connectivity is ubiquitous and boundless. So how should enterprises go about building a high-speed, stable network that adapts fluidly to new changes? To find answers, let's welcome Brad Casemore, Research Vice President from IDC, to give a speech about the trend analysis of intelligent IP networks.
Hello and welcome. I'm Brad Casemore, and I'm the Vice President of Research for Data Center and Multi-Cloud Networking at IDC. And today I'm going to take you through the need for intelligent IP networks, why they're necessary, and what sort of features they should have and what problems they should solve. So what is driving the need for network modernization? Well, enterprises are moving to a new stage of digital transformation You might call it DX 2.0 or Digital Transformation 2.0. And it involves using data-driven business processes and AI as an enabling technology. As enterprises take this journey and move along this path, they have to modernize infrastructure and operational processes to keep pace with their competitors who are also moving along the path of digital transformation and to meet the requirements of the digital business. It's important to have alignment between the infrastructure and the needs of the business, and that's why network modernization is so necessary. Now, these demands are placing extraordinary pressure on networks to evolve. More traditional static architectures need to be replaced by intelligent networks that offer extensive automation, application-aware experience assurance, and elastic scale. Now, NetOps must also evolve, so it's not just an architectural matter of modernizing your network, but you also need to modernize your network operations. And network operations needs to replace more traditional CLI-based management, this is manual management processes, with automated workflows and real-time analytics and visibility. That's so that they can get actionable insights that can enhance service availability and business resilience, which is increasingly critical in the current context as the world moves beyond the COVID-19 pandemic. That pandemic has really driven home the need for resilience in business operations, and the technology has to support that. So what does network modernization look like? Well, there's a growth and variety of applications that demand greater network scale and create greater network complexity. So as these applications grow both within the data center and out in clouds, you're dealing with a more complicated landscape of workloads and applications. And as a result, there's a need for new approaches to network operations. You might call it modern NetOps. And this should extend throughout the network lifecycle, from day zero network planning and design through day one deployment, and then on to day two troubleshooting and remediation, and then on to day N change management and network optimization. There's also a requirement for real-time analytics and visibility, and this is where AI-enabled technologies come into play, to yield actionable insights that ensure network performance and assure digital experience. And as applications come to the forefront of everything we do, including network architectures and network operations, that digital experience associated with the application really gains primacy. And ultimately, we are looking at the end of the day, the result should be network modernization that incorporates intelligent networking. So what does an intelligent IP network look like? What sort of attributes must it possess? Well, intelligent connectivity must serve as the foundation of an intelligent IP network architecture. Traditional networks lack mechanisms that ensure service level agreements between the network and the service or application layer. The network, as we move forward, must be able to accurately identify service intent by proactively discovering and learning about not only devices, but users, service types, and application types. And then it must further infer to meet expectations and requirements at that service or application layer. A unified network management plane in this new environment provides the control mechanism for the network. AI algorithms come into play here, and they're used to determine network models, detect and analyze network status in real time. It's very important that it be real time because applications need to constantly remain available, responsive, and secure. And then ascertain network resource availability and, again, real-time utilization trends. Accordingly, intelligent connectivity is a continuous process of matching service intent, what services and applications require, with network resources to provide optimal connectivity services as efficiently as possible. The result should be an intelligent network that, again, delivers that enhanced digital experiences, those enhanced digital experiences that are increasingly necessary as we move into more of a cloud-defined era. Another point that I think I want to emphasize here is the intelligent IP network needs to be ubiquitous. It can't just be in one part of the network or in one place of the network. It needs to span the data center network, the campus network, WAN and branch networks, and also it must incorporate intelligent network operations across all of them. So you need to be able to automate intelligently in terms of a network architecture, network infrastructure, and network operations across this landscape. As we move to the data center, what we're finding is that there is a real desire among enterprises and organizations generally to achieve a fully autonomous data center network as a major objective. They're looking at 90% of respondents to a survey that we did in June said that this is an objective of theirs. They want to leverage automation intelligently to achieve a fully autonomous data center network that works across the entire network lifecycle, from planning to provisioning and deployment on through troubleshooting and remediation, and of course through change management and optimization. And you can see it's true for industries right across the board. So clearly, there's a desire to have the network incorporate, the data center network incorporate more automation, more intelligent automation, so that it becomes more self-driving. So what does the intelligent data center network look like? Well, it should be declarative and intent-based. That's for simplicity of operations. And again, it should operate throughout the life cycle for both the overlay network and the underlay. And bandwidth requirements need to be accommodated, and they will increase as applications proliferate and become more varied. And we talked about the varying nature of applications, which will only have more variety as we move forward. One of the things that is happening as a result of virtualization and now containers is that we're seeing a growing wave of east-west traffic patterns in the data center, and you'll have to have a network that can address those. There's a need, of course, for real-time telemetry and visibility into cloud-native application flows. So virtualized applications are being supplanted over time by cloud-native applications, typified by containers and microservices, and you'll need visibility into those applications. And some organizations are increasingly considering network convergence as Ethernet becomes more capable. And they're looking at these converged networks to achieve cost savings, both in CapEx and OpEx, because rather than running multiple networks, or at least two networks, they'll be able to run one, handling SAN, storage area networking, as well as the primary data center networking. Now, this converged network will have to have certain attributes, obviously. It will have to have high bandwidth, and of course, Ethernet is able to accommodate that today. It will have to be lossless, and again, we're seeing tremendous advances there. And it will have to have low latency because you'll be dealing with elephant and mice flows across these storage networks. What about the campus network? Well, the campus network is also seeing change, and there's again a requirement for more bandwidth there. As 5G and Wi-Fi 6 enabled smartphones will proliferate in the months and years to come, they're going to drive much greater use of mobile applications, rich mobile applications, and they will require, and they're going to basically consume a commensurate amount of data. The result will be a need for more bandwidth, which will be required in the campus access networks as well as in campus cores. Now there we're seeing multi-gigabit Ethernet adoption come into play, and certainly it serves a valuable role there, providing the bandwidth, ubiquitous bandwidth that will be required for workforce engagement and productivity. And we also see a role for 5G uplinks and optical transports to provide one-hop cloud connectivity. Traffic volumes will grow further in the campus network as scores of other connected devices are added to the campus network. So there's a lot of embedded devices that will be added to the network. Printers will have IP addresses and continue to have IP addresses, of course. More and more devices on factory floors will come into play on the campus, and they'll all have IP addresses and will be connected. And we'll need new forms of network security as this happens, including intelligent behavior-based analytics that can sense anomalous activity and proactively identify suspicious application, device, or network behavior, which can be used to provide effective enforcement and protection across these networks. And it's important to illustrate here that the campus network must not only provide ample bandwidth, but also feature reliability and security through declarative policies. Again, it needs to be managed simply. And the ultimate goal is to deliver that application and experience assurance. Now we move to the WAN. And this is a result of a survey that we did, our software-defined WAN survey. And we asked respondents in enterprises worldwide to identify the 3 most significant WAN challenges that relate to their company. And you can see that security requirements were right at the top, relating to IaaS and SaaS cloud services and other internet applications, but also the complexity of dealing and interconnecting with multiple transport types, including MPLS, Ethernet, broadband internet, lease lines, DSL, and 4G LTE. And of course, we'll have 5G coming into play. They're concerned about managing that consistent digital user experience in the branch and including in the branch for off-premises applications, as well as their more traditional applications that reside in an on-premises data center. And they're also interested, of course, in cost-effectively delivering SaaS and other cloud services across the WAN and many other things besides. And they're looking at better analytics and visibility, as we said earlier. So you can see all the things that we talked about before in the campus and the data center. There's some commonality in terms of requirements at the WAN, although obviously the WAN is a different place in the network and has its own requirements as well. So what is required at the intelligent WAN branch? Well, WANs face the need for transformation as branch offices and remote sites must quickly, reliably, and securely connect to applications that reside in SaaS and IaaS clouds, as well as those that are still in on-premises data centers. SD-WAN plays a valuable role here in ensuring that network and security policies are consistently applied to support delivery of applications and services. On-premises applications, SaaS applications, IaaS workloads, and internet-based services all require different application policy that governs how they're treated by the network. Transports include broadband, Ethernet, MPLS, and 4G, as we saw in our survey, and 5G is increasingly used for primary and secondary connections at a growing number of branches and remote offices, and we'll see more of that as we move forward worldwide. 5G can also provide last mile connections for branch backhaul. And SRv6 is now being used to provide value in modern WAN routing, with more and more use cases coming to bear for the technology. What about operations? We've covered all the places in the network, but now let's look at intelligent operations. Well, changes to operational models and automated processes are essential to greater agility and better business outcomes. Here is where network visibility and analytics play an essential role in enhancing the productivity and business relevance of network operators. So this is a chance for network operators to play a meaningful role in delivering on basically digital transformation and also delivering business outcomes. The network life cycle from day 0 through day N, as we mentioned earlier, must be thoroughly automated to align modern NetOps with DevOps and the whole DevOps practices and principles. And this assures that applications are provisioned quickly and remain available. Organizations can start their journey along this automated network operation path with simple recurring O&M processes that minimize risk and help them gain confidence. And they can use industry standard protocols to maintain flexibility and protect against lock-in as they proceed along this path. Now, just to wrap up, in terms of essential guidance, I think I want to leave you with the thought that enterprises are moving to a new stage of digital transformation, this DX 2.0 that I referenced at the beginning of the presentation. And it involves data-driven processes and AI as a key enabling technology. What this means is that the network must be modernized, not just one part of the network or certain aspects of the network, but the entire network. Networks can deliver on the agility the business needs with the control and security that IT requires. And of course, it's important that those two be reconciled. And they can do this by providing intelligent automation in all places in the network and throughout that network life cycle. This requires modernization of architectures, infrastructure, and operations. So, if you just do one or even if you just do two, you won't see optimal results. Organizations can start their automated journey with simple, repetitive O&M tasks, and they can become more ambitious as they gain confidence and they gain trust in the operational model and the technologies that underlie it. The destination ultimately is more agile network infrastructure, more automated network infrastructure, and more autonomous network infrastructure. And with that, a more proactive approach to NetOps. Thank you very much. I've enjoyed being with you today, and I hope you enjoy the rest of the program.
Thank you, Brad, for your insightful speech. Digitalization has become a new normal. What kind of campus network will your enterprise need? To find out more, I'd like to invite Henning Czerny, CTO of Network Solution Huawei Germany Enterprise Business Department, to deliver a speech entitled Building a Fully Wireless Intelligent Campus Network.
Campus networks are nowadays in tremendous transformation, coming from the PC era where just PCs were connected by cable and Wi-Fi was not that important and communication was mainly locally and in north-south direction. This has completely changed in the recent years. My name is Henning Czerny and I'm CTO of Huawei Germany networking team. Today, in the next 10 to 15 minutes, I want to take you on a journey to learn more about fully wireless and intelligent campus networks. The transition from PC era to the cloud era is essentially a process of digital transformation. From the perspective of digital transformation, wireless terminals, global network connections, and cloud-based IT applications will all become the IT trends in the future. The number of wireless terminals is increasing by hundreds of times. With the deployment of enterprises, traditional IT networks have evolved from independent branch local networks to globally accessible networks, enabling global service interworking on a single network. At the end, 80% of global enterprise services are deployed in the cloud, may it be public or private cloud. The era of on-premise application deployment is simply over. However, we are seeing that 70% of enterprise IT is still in the traditional infrastructure model. With digital transformation and the evolution of enterprise IT and campus networks, we are facing several challenges. Wi-Fi and mobile connectivity is more important than ever. Together with the fact that users are expecting high-quality internet working everywhere on the campus, the Wi-Fi network is becoming the heart of the campus network, and coverage holes or interference issues cannot be accepted anymore. But not only limited to one building or site. Together with globalization, enterprises must provide secure and reliable connectivity at all their sites around the globe. With unified policies, centralized management, and intelligent O&M. Based on these challenges, we believe that campus networks in the cloud era must have the following features. Unified wireless network management, massive wireless terminal access capabilities, and the integration of Wi-Fi and IoT to reduce interference are key features for all wireless access networks. All wireless networks with these features can enable new enterprise services brought by new wireless terminals. Future enterprise networks provide services across the headquarters to multiple branches. It will be networks that support multi-service barrier to meet the global service deployment of enterprises. In the cloud IT era, cloud-based networks need to be matched. Cloud-based networks are used to drive networks and implement network automation, including end-to-end SDN network automation capabilities from LAN networks to wide area networks, and even wireless LAN networks to adapt to the rapid changes in the cloud era. In the cloud IT era, networks need to be operated in a more intelligent manner, which enables predictive network maintenance and proactive optimization of users and application experience, making enterprise network services much more reliable. To address this issue, Huawei launched Cloud Campus 3.0, a cloud-oriented all-wireless intelligent campus network that implements all wireless continuous networking through all scenario Wi-Fi 6 and intelligent optoelectronic technologies, enabling wireless to replace wired networks and breaking down enterprise organizational boundaries. Cloud Campus 3.0 improves innovation efficiency by 40%. The exclusive SD-WAN technology enables thousands of branches to be agilely migrated to the cloud, building a global enterprise network and reducing interconnection costs by 40%. All cloud management enables O&M personnel to access WAN, LAN and WLAN networks no matter where they are. Both can be easily managed, reducing OPEX by 50%. Intelligent O&M enables visualized experience of each user application at any time. Proactive O&M will analyze network quality so that the live network faults can be rectified in minutes and IT personnel can go for a stop and a cup of coffee. As said before, Wi-Fi is rapidly becoming the basic IT infrastructure of enterprises. However, with the increasing application scenarios and diversified application types, higher networks requirements are posed. For example, 4K conference in office scenario requires more than 700 megabit bandwidth per second, and augmented reality and virtual reality services in education requires less than 10 milliseconds network latency. In industrial production scenarios, the network must be capable of 0 packet loss. Although these services can be met on wired networks, but wired networks do not have mobility, which limits application scenarios. Traditional Wi-Fi 5 networks cannot meet these service requirements due to technical capability limitations. Wi-Fi 6 networks improve bandwidth, latency and capacity, but lack deterministic experience. Huawei has accumulated decades of wireless technologies based on the Wi-Fi 6 standard. These problems are resolved by optimizing antennas, radio frequencies and algorithms. Wi-Fi 6 enables various enterprise services to wired-like experience and so finally enabling wireless services to replace wired networks. Wi-Fi 6 really can replace wired networks. The biggest challenge for Wi-Fi networks is continuous networking. When traditional Wi-Fi networks are deployed on a large scale, problems such as code channel interference, coverage holes and roaming interruptions are inevitable. To solve these problems, Huawei Wi-Fi 6 introduces industry-leading 3D network planning, which enables a campus planning of maybe 10,000 users to be completed within just 30 minutes. In addition, Huawei uses unique 3D simulation mode to simulate coverage and roaming quality, making wireless network planning much more accurate. In addition to solve code channel interference and coverage holes, Huawei uses industry-leading smart antennas to achieve 0 coverage dead angle and increases the radius by around about 20%. The most important thing is that signals are enhanced at any location. To address the issue of frequent roaming interruption, Huawei introduces the exclusive AI roaming technology. This technology learns roaming behaviors of users and accurately guides users to roam during mobility, implementing fast and lossless handovers. The roaming success rate on the entire network can reach over 69%. These innovations do not only improve wireless network reliability, but also provide continuous user experience. The speed of wireless networks has always been the ultimate goal of enterprises. To increase the speed, powerful Wi-Fi 6 solution is a must. As an example out of the Huawei portfolio, I'd like to introduce the Huawei Air Engine 8760, the fastest Wi-Fi 6 AP in the industry. It has a rate of 10.75 gigabit per second and smart antennas, the best in the industry. The exclusive massive MIMO algorithm improves the multi-user concurrency capability by 40%. To meet the access requirements of more and more IoT terminals, the Wi-Fi 6 AP also has 2 built-in IoT card modules to easily converge Wi-Fi and IoT. One device, one wireless network can provide wireless terminal access anytime and anywhere. The AP also has independent radio scanning capabilities. With this independent radio, the AP can detect network quality in real time and optimize interference without affecting wireless network services, ensuring optimal user experience on the entire network. With the cloudification and globalization of enterprise branch services, 58% of enterprise services will be migrated to the cloud by 2025. How to help enterprises quickly, smoothly, and stably migrate to the cloud? Huawei SD-WAN solution builds a network that connects multiple branches and clouds to ensure high-quality user experience for mission-critical services. 5G gigabit wireless access anytime and anywhere, and network provisioning just within 1 day, supporting rapid service expansion of enterprises. It supports flexible access of multiple wired and wireless links such as 4G, Ethernet, DSL for on-demand interconnection. Flexible networking capabilities enable smooth migration of existing enterprise networks. Huawei Cloud Campus provides all cloud management from LANs to WANs. Unified policy configuration and delivery are implemented for switches, wireless LAN, routers, and firewalls. Devices on the entire network are plug and play and deployed just within minutes. It provides automatic network topology orchestration, intelligent traffic steering, optimization, quality of service and end-to-end security policy automation, and intelligent recommendations to ensure key application experience. It also provides all cloud visualized O&M, GIS-based visibility of applications, links, sites, and network-wide devices and fault location within minutes. The number of wireless access users increases exponentially. The number of wired ports increases exponentially. And user experience changes at any time. The scale of enterprise networks is far more complex than you can imagine. IT professionals and CIOs are asking us how to easily deliver and maintain networks. Huawei uses the Campus Insight Intelligent O&M solution, especially the exclusive wireless network optimization technology to improve network-wide performance by 85%. In addition, the wired and wireless fault rule database is continuously enriched to proactively identify and locate root causes just within minutes, rectifying potential faults by 58% and greatly reducing the user complaint rate. In addition, Campus Insight builds a complete and refined O&M solution based on application. It accurately identifies more than 1,000 mainstream applications, including Office and Skype, for instance, based on precise application identification technologies. By using the exclusive EDMI technology and intelligent algorithms to detect the quality of key applications in real time, it provides intelligent analysis based on users, applications, and devices. The exclusive IPCA technology is used to demarcate faults for poor QoE applications just in minutes, achieving user experience of each user and each application at any time on the entire campus network. The all-wireless intelligent cloud campus network solution redefines a big framework for future campus networks. Huawei can also provide scenario-based products and solutions which are called Cloud Campus 3.0 plus X. In the industrial Ethernet scenario, the exclusive industrial-grade CPE enables production equipment to cut braids to easily adapt to flexible production in factories. In rail transit, the new Wi-Fi 6 vehicle-mounted AP provides high-quality wireless access. In smart energy, the next-generation 5G edge computing IoT gateway can easily manage device-side devices. The new generation SmartX intelligent backhaul applications ensures city safety without power supply. We also hope to work together with you to explore more business requirements and enrich the Cloud Campus 3.0 plus X application scenarios. There are many very good reasons why Huawei Cloud Campus 3.0 should be your choice in next generation campus networks. And many other users and enterprises have already made that decision. In Wi-Fi 6, Huawei was the first vendor on the market. We are the main contributor to the Wi-Fi 6 standards, and we have the most powerful portfolio. Huawei is leader in optical communication markets for many, many years now, and already number 2 in the global switching market for 5 years now. Our net engine routers have the highest market share globally in 2020, and last but not least, the best argument is many thousands enterprises that trust in Huawei products and solutions, offering secure and reliable connectivity to hundreds of thousands of users. Thanks for watching.
Thank you, Henning, for your meaningful sharing. Next, I'm honored to invite Mohammad Badar Farouk, Senior Solution Architect of Network Solution, Huawei Middle East Enterprise Business Department, to deliver a speech. The title is Building the Industry's First L3 Autonomous Driving DCN with Intelligent O&M.
Hello everyone, my name is Mohammad Badar Farouk. I am the Chief Technical Officer for Data Center Solutions in Middle East Network Solutions Sales Department, Huawei. Today we will talk about how Huawei is building the industry's first Level 3 autonomous driving data center network with intelligent O&M. Before we start, let's see what happened in the last year or so. The pandemic hit. It brought a lot of changes to our lives in everything. How we work, how we live, how we do any shopping, everything changed. When everything switched to online during the COVID-19 pandemic, it had a lot of impact on digital financial services. Well, look at this, that 300 million people are working from home just in China. So you needed remote office applications. Then, instead of going to the doctor themselves, telemedicine saw a 9-fold increase. Education went completely online. Only in China, 270 million students were attending classes from home. The grocery shopping, instead of going to the mall, the online grocery shopping went up 350%. And then almost all the government services went to an online model as well. Now, if you look at the financial industry, what happened? They had sluggish offline services. The new customer acquisition were declining. Why? Because people were not going to buy a new, people were not going to the bank for a new debit card application or a credit card application. Also, there were adverse impact on the banking services such as retail cards, small and micro enterprises loans, because these services needed in-presence requirement, and there were no online service to actually give small loans to the customers. And there were also a decline in the intermediate business, an obvious drop in the retail transaction because people are not going to the shops. Where the offline services were sluggish, the online economy was booming. The China Merchant Bank has lent a total of 23.7 billion in just 3 weeks, and the loan utilization in the cities were almost 100%. This is the remote lending which was done online. Similarly, utility bill payment, significant increase in the bill payment across multiple banks such as China Construction Bank and China's Merchant Bank. So we could see that during the COVID-19 pandemic, the offline services were suffering while the online economy was booming. Now, looking into that, now if you look into the problems and challenges facing the financial data center networks, there are multitudes of problems. The first problem is that it's not one data center. Most financial services institutions have multiple data centers, and they are built on a multi-cloud, multi-location, multi-model architecture. Some of the workloads are in the private cloud, some of the workloads are in the public cloud, so you need a complex multiplex network deployment, which is quite difficult to do. When we talk to a particular customer or any financial industry customers, they have the same problem. Half of the engineers are engaged in network design and change assessment every month. Then, if you look into the requirement changes, because you have multiple type of devices and complex configuration, the change impacts cannot be verified. If there is a change in one side of the network, it can impact the full network and it can cause problems. So approximately 40% of the network faults are actually caused by human errors, leading to multiple major accidents and downtimes. And then services are becoming more and more complex. How do you deal with problems in the network when you have the traditional O&M model, which is passive fault detection and experience-dependent fault locating? If you take a survey, and overall industry average of locating a fault and troubleshooting is 76 minutes. This is very, very low efficient. And in today's time, a data center fault, if it is taking 77 minutes, is just not good enough. During our conversation, one of the customer network department actually told us that even though we work day and night to handle network issues, we still receive the most complaints every month. This is the reality of the complex times and the increasing requirements of data center networks in the financial industry and in all other industries. To solve these problems, Huawei has launched a data center ADN solution. ADN stands for Autonomous Driving Network, and what it is? It is a network that can, for a large extent, can run itself. The network is based on intent automation and intelligent O&M for multiple and hybrid cloud scenarios. We will go into the technical details of this environment, but let's see what are the two differentiators of Huawei. Our first differentiator is intelligent A&N deployment. We have 3 times higher deployment efficiency than industry, 0 wait, 0 error, and 0 interruptions, the 3 zeros. And we will go and see how that works. And the second differentiator is our O&M. It is AI-powered 135 intelligent O&M. 1 minute to find a fault, 3 minutes to locate the fault, and 5 minutes to rectify the fault, making the breakthrough in the projects. Our first differentiator is intelligent ADN deployment. We claim that we have 3 times higher deployment efficiency than the industry, and we preach the 3-0 model: 0 wait, 0 error, 0 interruptions. How does this actually work? First of all, the deployment part, we have 21 service intents built into the overall architecture of the solution, which means that the planning, design, deployment, all of that can be automated through intent translation methods. This increases the deployment efficiency 90%. If you look in the industry, there will be a lack of automated network planning and design, there will be complex operations, and you will have to switch multiple GUIs to do one configuration, resulting in low efficiency. Then we have a 0 error configuration. Now, once you are deploying the configurations using software-defined networking, software-defined networking adds an abstraction to the network. Now, you can deploy a service, but you are not sure about the impact of that particular deployment on the overall network. It can cause some problems to an unrelated service, it can cause connectivity issues, and it can cause an error which is actually caused by the configuration. What Huawei can do is a pre-event AI-powered simulation and post-event verification. That means that we can deliver the configuration free from errors, and the configuration accuracy is 100%. In the industry, there is a lack of pre-event simulation. 40% of the network faults are actually caused by doing configurations by the engineers themselves. And then the last part is 0 interruption. The network can run into problems. Sometimes you need to do a rollback of a particular configuration that you did. Huawei offers industry-leading 3-level rollback options. You can roll back network-wide, which is very fast. We can do the whole network rollback in 20 minutes. You can do it only for a particular tenant that is experiencing problem, and we also support only on a service level. So this 3-level rollback based on the fault impact scope. If you look in the industry, there is a lack of service rollback. If you have to roll back a particular configuration, you will have to roll back the full tenant configuration, even though of only a particular service is causing a problem. It's basically, what does it mean? That you have a problem in a small subset of a network, but you have to roll back a large network configuration. This is not efficient, and it takes a lot of time. Our second differentiator is our intelligent ADN O&M solutions, where we have AI-powered 135 intelligent O&M, where we are making breakthrough in the projects. Now, basically, what is it? We do a real-time network health monitoring, and we look into 70+ indicators. We collect the data in milliseconds using telemetry, and then in real time, full information network collection is done on the network and modeled. Think of it like I want to go from one place to another place. And think of it that you are using a map application versus a manual map. A map application is going to give you all the information you need, while on a physical map, you will only be able to see a particular path. So there is no systematic evaluation between them. It is based on manual experience. Then let's say there is a fault happened. How do you figure out there is a problem? We have fault root cause location built into the platform. An AI knowledge graph is constructed, and we do 135 intelligent O&M, locating 75% of faults. Think of it again like an example that you want to go from one place to another place. And you looked into a manual map and you started to go to that particular place. You are not sure about real time what is happening. If there is a blockage, you are not sure about the root cause. And then if you want to do a service change, you want to make sure that there is service assurance, right? Now, we have 24/7 automated intent verification on the data plane, which means that anytime we are going to do a service change, we can ensure that the mission critical services are not affected. So, based on the full knowledge graph and the complete knowledge, we can predict what is happening in the network. We can assure that when we are performing the O&M operations, our critical services are not impacted. On the other hand, if you look into industry, think of it like a road condition prediction. If you don't know what is happening and you read a blockage, then you are just going to turn to a blind path, not knowing what lies ahead of you. How do we build the ADN system? It is built on one foundational idea and three key technologies. The foundational idea that we built our ADN system is the digital twin. We will go into a little bit more detail in the next slides, but basically a digital twin maps a physical network to a digital model. It unifies data models, shielding network differences. For example, you have multi-vendor environment, or let's say you have different kind of devices. One logical model or one digital model can combine all the different models that you are using in the network. With central data warehousing and recording data at every moment, we can build a digital twin of your actual network in the data modeling itself. Then the three key technologies that enable ADM are intent-driven recommendation, which means the staff doesn't have to think about the service intent and objective interpretations. Then the simulation verification, which means that we can look into all angles via data calculation before deploying a configuration. And the last one is the intelligent analysis, which breaks experience dependent analysis limitation. Now let's look into these three key technologies as well as foundation one by one. We do data verification, avoiding human insufficient considerations. What are the challenges? When you are deploying a configuration in a software-defined networking, based on the abstraction of the software-defined model, sometimes you do not have the full picture. You are not sure that whether a configuration or a change that you are deploying to the network, what will be the impact across the network for another service or an unrelated service, for connectivity across another data center. And when these configurations are deployed, they can result in errors. 40% of the data center network faults results at a part of human errors. Evaluation of network change impacts takes time, and it takes a lot of expert experience to do that, and even in that time it is difficult to imagine. But on the digital twin based simulation, what can happen? Because you already have a digital twin model built in or calculated based on your network status, based on the unified data modeling, what will happen? Any network change that we are about to perform, we can run a high precision dynamic digital simulation over your digital twin map. And based on that, by running an optimized formal verification algorithm, we can ensure that we can get an accurate result of any network change that you are going to perform before you even perform the change. Now we know what will happen when a particular configuration is going to be performed. And once we know what is going to happen and we can verify it with an algorithm, once we deploy the configuration, there is not going to be any problem. Think of it like this, that if I want to decorate my home, what will happen? The designer is going to do a 3D modeling of your home and then design the decoration, so you will know that the sofas and the curtains are going to fit your actual house. This is what happens. Based on the digital twin modeling, we can figure out what will be the impact of the changes that we are going to do. The third part is related to the O&M. The machine-based decision making can break through the upper threshold of manual experience-based decision making. What are the challenges? Generally, when there is a problem that happens in the network, you have to solve it manually. An average of 76 minutes is required to locate a single fault. And generally, how the fault is, reported. The passive O&M doesn't tell you there is a fault. There is a service complaint that you receive, and then you collect the packets, you try to figure out what is happening based on the expert experience. There is a problem, there can be 6 or 7 different reasons for that one. You go through them one by one, finally arriving to a conclusion of a problem. The whole process takes time. And then there are certain faults that you cannot even figure out. 70% of the potential risks are hard to detect. Think of abnormal flows in the network. They are not triggering a MEB, but they are a problem. How do you even figure out these kind of problems that happens in your network? This is where our O&M solution comes in. The machine-based decision making based on the knowledge graph. We collect the data based on the telemetry, and then this data is fed into our artificial intelligence-based big data engine. We have a network-wide inference based on the knowledge graph. So basically, by collecting all the data, we build a knowledge graph in your network. And then, whenever there is a problem and whenever there is an issue, what happens? We run the whole process of root cause analysis on the machine itself. And if we can figure out what happened exactly, and then we can recommend a solution to solve the problem. The overall, we call this 135. The fault can be detected in 1 minute based on the fast collection of data with telemetry. We can figure out the location or the root cause of the fault in 3 minutes based on the knowledge graph, and we can rectify the fault within 5 minutes based on the recommendation as well as interconnection of our solutions with each Fabric Insight within CE Fabric. Think of it like this. You are playing chess, right? At any given time, maybe you have 100 different moves. A human being will have to think of all those moves one by one to decide which one to pick. A machine can do all of them very, very quickly. Now, let's take a typical application case. We want to deploy a service in a financial industry. What is the typical process if you don't have an ADN solution? For the service we want to deploy is micro and small loan service provisioning. That is the service intent. Now what we want to do is we want to translate into a network design. So we will translate to a network intent, and then we will try to figure out what to do. To deploy this particular service, I have to do configurations in my web, database, as well as storage clusters. So I will need 3 work orders for that. Since the service has to be online, it needs also the access to the internet. So there will be a service deployed to the internet egress part, and the service will be deployed across multiple data centers. Now there will be a work order for that as well. When I will try to deploy the network, I will look into the 2 data center configurations. I will configure the 3 places, web database applications, as well as internet egresses, and deploy the full configuration. The whole process, translating a service intent to an actual network configuration, is going to take time. But on the other hand, when Huawei ADN solution is deployed, the service intent can be automatically translated, resulting into very fast service provisioning. I'll show you a video now to tell you how exactly that happens. In this video, you are going to see that we select a service intention type, and then after that, the whole mutual access relationship of the services is automatically mapped out. The system starts looking for a suitable network solution, and then a network solution is recommended. The network solution is recommended based on 3 different models: best security, best SLA, fast rollout, for example. So 3 optimal solutions are recommended. Once the optimal solution you select, then the solution is actually simulated to make sure that the solution is not causing any other problems. And once you are happy with the result of simulation, the solution is automatically delivered to the devices. So the whole process of translating a service intent to eventually deploying a configuration that would have taken a lot of days and a lot of work orders can be automated from our autonomous driving network solution. The Trolley test shows that Huawei data center network is the first to achieve level 3 ADN. What does it mean? We think there are 5 levels of reaching a totally autonomous driving network. We are not there at the moment where the networks can completely run by themselves, but Huawei is the first network solution that has reached level 3, which means that we are highly autonomous. Now, why it is that? Trolley tested us into the full life cycle of data center network deployment. The phases of the data center life cycle are divided into day 0, day 1, and day 2, and day n. Day 0 is when we do planning and design and deployment and provisioning. Huawei achieved the highest score there based on this ADN solution. Day 1 is where you actually deploy the services, and here Huawei service intent translation and recommendation meant we again received a very high score. The day 2 is monitoring and troubleshooting, and day n is parameter adjustment and network change. Huawei ADN network solution covers the full life cycle of data centers from day 0 to day n, and in this way we have achieved the layer 3 autonomous driving network solution already, and eventually in the next few years we will be achieving level 4 and level 5. So in 2015 we were in level 1, assisted O&M. In 2016 to 19 it was a partial autonomous network. In level 3, which is now, we are in the conditional autonomous stage, and very soon we will be going into highly autonomous stage. The vision eventually is to reach an L5 fully autonomous data center. And Huawei's solution has been deployed in large financial institutions all over the world. Of course, the largest bank in the world, ICBC, and almost everywhere in the financial industry in China, the solution is deployed, and not only there. In Bradesco Bank in Brazil and the very large bank, Sberbank in Russia, the ADN solution has already been deployed, and with these vendors, with these particular customers, we worked in a joint innovation fashion to deploy this solution. That is the end of my presentation. I hope you were able to understand the Huawei vision for autonomous driving network and what our solution offers. Thank you for your time.
Thank you, Mohammed, for your meaningful sharing. Let's invite our next speaker, Mr. Arkadiusz Giedroyc, CTO of Network Solution, Huawei Nordics and CEE Enterprise Business Department. He will deliver a speech about building an IP network with deterministic experience based on Cloud One. Let's welcome Arkadiusz.
Hi, I am Arka. I'm working for Huawei Central Eastern Europe and Nordics Regional Office. In this session, I would like to tell you how to build IP network with deterministic experience using Huawei Cloud One solution. Since many years, as probably all of you has already spotted, data has become one of the most valuable assets for IT organizations. In fact, in some of the countries, for example, China, the data is considered as a new production factor along with the traditional ones like land, labor, and capital. The data as a new production factor can create value by flowing, sharing, or processing. From this perspective, connectivity networks create for modern digital society a relation between people, machines, and things. So when we look at the data and its flowing, we can determine two major trends on the market. One is so-called cloudification of IT enterprise system, and the second one is digital transformation in industrial production systems. For enterprise cloud IT solutions, organizations can easily create innovative services and provision them rapidly. Unfortunately, in many cases, network cannot keep the pace of IT cloud services. For the industrial production networks, quite often customers are really preferring safety, security, and stability over speed and efficiency. When we also look at the networking solution for those two trends, what we can spot is that for the enterprise IT systems, we have the proliferation of mobile application and availability of mobile internet, which in combination with increasing speed in the data centers network quite often put a lot of stress on wide area network deployments. And in many cases, those deployments are insufficient to fulfill the requirements of the modern cloud data centers. For the industrial production networks, they've been typically built to transmit mainly control information. And right now, when the field is undergoing digital transformation, and right now there are new business models which require the intelligent cooperation with ecosystem, cooperation with new intelligent terminals, and cope with the industrial internet, those networks are also insufficient. And the question is, can we build a network which meets such a demanding requirements? So before we will go into the topic how such a network we can construct, let's face the major challenges in front of us. So first, when you look at the data, almost 93% of the enterprises are using public cloud in any form. Also, 74% of the enterprises are using hybrid cloud deployments. IT cloud environments allow organizations quickly obtain computing and storage resources and quite a low prices, and use cloud applications to perform big data analytics which support decision making. Unfortunately, bringing those services over the network is a hard case to do. And the main reason is that traditional networks are built with MPLS technology, which is deployed segment by segment and requires a lot cross-department cooperation. As a result, service provisioning over the network may take weeks or even months. Second challenge is that for the industrial co-production networks, they are quite often based for its transport network on SDH. New business models which are coming from digital transformation, as we have already mentioned, require a lot of cooperation with new ecosystem between the departments, with the intelligent terminals, and so on. Unfortunately, the SDH networks suffer from poor scalability and they are not so open for changes, which makes them a little bit not sufficient to meet current wide area network deployments and requirements. The third challenge is related to scale. In such a big countries like, for example, Russia or China, large enterprises generally require nationwide network deployment, involving numerous layers and hundreds of network element deployments. In such an environment, traditional operations and management procedures and processes does not really work, and they are inadequate. It is very hard to use them in order to quickly identify and resolve problems, which really leads to low efficiency in fault location and resolution. So, how to build a network which is dealing with all the issues that we have already mentioned? So, we believe in Huawei that such a network has to have 4 characteristics which are very important to construct such a network. First, we have to match cloud speed and agility with network deployment, which I mean is that we should be able to deploy service over the network in a very short period of time, which matching the time of creation and deployment of cloud services in a cloud platform. The second one is that we should use one fiber connection for multi-purpose network, which we called intensive network construction. And this deployment of one fiber for multi-purpose network should create us efficient networks, but maintaining in the same token reliability and security between those networks. The third characteristic is that we need to maximize resource utilization in our cloud data centers. In Huawei, we are using intelligent path selection algorithm, which enable really to maintain the proper access to the storage and computing resources which are least used, making it the balanced resource usage and maximizing resource utilization. And the fourth one is that such a network has to have intelligent and automated operations and management system, which is using telemetry and artificial intelligence algorithm to deal with management of vast amount of network elements and also with enormous amount of telemetry data which are coming to such a system, enabling really to fast identification of the problems and also quick risk detection in advance. So Huawei came up with the Cloud One 3.0 intelligent wide area network solution to address all the challenges, and our solution has all the characteristics that I have mentioned just one slide before. Our solution is based on IP as a foundation technology, and it's really cloud-oriented in the way that we deploy it and in the way we provision it. And this one solution has we call 4 ones capabilities. One hop, one fiber for multiple network purposes, one click fast scheduling, and one network-wide connectivity. Let's look at them one by one. So first, in one hop to the cloud solution, we are using our iMaster NCE plus segment routing version 6 technology, which allows us to break the segmentation and cross-department restrictions of traditional MPLS network. In this way, we can implement one-hop service provisioning and one hop to the cloud within very short period of time. This allows us to really match the agility and speed of cloud services provisioning. Moreover, segment routing version 6 is replacing numerous complex protocols, making network simpler. In this way, decreasing the operational costs of the network. Second, the new network deployment has to eliminate private network silos. With Huawei deployment using slicing technology, we can do this. We have a patented technology which is called the fingerprint-based slicing, which allows us in a very short period of time to provision up to 1,000 slices. In this way, we can achieve a one fiber network deployment for many cross-department networks which are isolated using slicing technology and can carry numerous different services. The third is the one-click fast scheduling. And one-click scheduling is focusing really on our intelligent cloud graph algorithm, which can collaborate using APIs with a cloud management platform and allowing us to plan and schedule the network deployments which are taking under consideration the utilization of resources like computing and storage, making it the solution to fully utilize the resources or pool of resources that we have available in our internet data centers. The fourth one is one network-wide connection. Under this characteristic, what we understand is that it is the combination of our iMaster NCE capabilities together with the iFit technology, which is the telemetry technology, and it uses in situ OEM frames, which are inserted into different type of protocols, which we can insert per flow, and which allows us to really detect in a real time problems relating to the flows and also control several SLA related KPIs. Also, iMaster NCE enables us to have the visualization and the status of all the resources in the centralized manner and manage large number of network elements, achieving one network-wide connection. As I have said, our solution is not only slide set solution. We have also real-life deployments. One of them is EPM Columbia, which is the power grid operator when we have deployed the Cloud One 3.0 solution already, when we are using the one fiber for multiple networks, when we are using slicing technology, and iMaster NCE to control everything. This allowed this customer to really cutting the CapEx expenditures by almost 40% and improve operational efficiency almost to 25%. One of the most important elements of building the Cloud One 3.0 solution is our new NetEngine Series 800 routers, which allow you to build one hop to the cloud, one fiber multiple purpose, one click fast scheduling, and one network-wide connection Cloud One 3.0 solution in combination with our iMaster NCE platform. I hope that I've been able to describe you in a high level how new Cloud One 3.0 solution from Huawei can address the new challenges and requirements which are coming from the modern network. Thank you very much for your attention and have a good day.
Thank you, Arkadiusz, for your wonderful speech. As a leader in the ICT industry, Huawei has also built a secure, reliable and stable IT network for its office and production campus. To understand how everything fits together, let's explore Huawei's Songshan Lake campus, located in Dongguan, China.
Hi everyone, I'm Bob Chen. Welcome to IP Club. a fully connected, intelligent world is fast approaching. Campuses will become the seals that carry all the DNA needed for this world. Recently, my friend asked me why we often see wireless and intelligence as the main features of campuses. Has Huawei's campus become fully wireless and intelligent? I replied, yes, absolutely. Today, my colleague will take you on a tour of a fully wireless, intelligent campus, the Huawei Songshan Lake campus. I'm sure you will find the answer there. Okay, let's get started.
Hello and welcome to our Songshan Lake campus. I'm Wu Fan, one of over 100 Huawei employees who are dedicated to helping our customers succeed in over 170 countries and regions. Our Songshan Lake campus is located in Dongguan, China. The campus has over 600,000 square meters of office space, 200,000 square meters of labs, and more than 800 meeting rooms, 15 canteens, and 10 coffee shops. Over 25,000 employees work here. Today, I want to share with you how our campus network makes a difference. At Huawei, 2.8 million emails are sent every day, while more than 600 applications are running our network system, including IPD, ISC, CRM, IFS. Without this process, platform, or application, Huawei employees simply cannot work. But what empowers this system? The secret is a secure, reliable, and stable IT network system. Huawei IT has undergone 3 phases of development, that is, globalization, digitalization, and intelligence. Our Songshan Lake campus is designed and built in line with the 3rd phase, which includes intelligent workspaces, services, and production. All of these are built on a unified network architecture, which defines dozens of standard service modes and combine this service mode to serve a variety of scenarios. In a moment, I will show you around this unique campus. As we drive into the campus, our phone notifies us about real-time parking spaces and routes. Simply picking a free parking space will then bring up the directions to get there. Even at peak hours, our administrator can flexibly allocate resources to guarantee the best experience for VIP. How do we achieve this? Well, the answer is smart radio, lossless roaming, and precise positioning, which is powered by Huawei's Air Engine Wi-Fi 6. Next, I will let my colleague to introduce our meeting booking system.
Hello everyone, my name is Guo Peng. Next, I will show you how we book a meeting inside Huawei. To ensure all the meeting rooms are used as much as possible, all our meeting rooms are networked and digitally transformed. A tablet is installed outside of each meeting room to display real-time information. All of this powered by our central IT platform, ensuring a smooth room booking service and greatly improving team communication and collaboration. As soon as we enter the meeting room, the curtains close, the lights and the air conditioner turn on automatically. The enabler behind the comfortable environment is the built-in IoT modules in the Wi-Fi 6 APs. In each meeting room, tablet, computer, smartphone, and large screen are connected using wireless network, supporting smooth switching between screens. The high bandwidth and low latency of Wi-Fi 6 allow us to enjoy uninterrupted experiences while using CAD, our real-time video and voice services.
All of our offices at Songshan Lake campus have now become fully wireless. Previously, wire network were used, where one network cable had to be routed for each cubicle. This means that network deployment was complex and time-consuming. But now, we can use a single AP here to connect to dozens of even over 100 users at the same time, which greatly simplify deployment and network access. As Wi-Fi 6 is rolled out, we have upgraded the ordinary access switch to hybrid optical-electrical multi-G switch. Such switch can auto-negotiate for 2.5, 5, or 10G speeds on ports. They can also work with hybrid cable to supply directly connected APs and cameras with 60-watt PoE++ at an ultra-long distance of 300 meters, breaking the 100-meter limitation and previous PoE. This ensures reach anywhere on each floor, significantly simplifying cabling and saving valuable equipment room space. We affix RFID tags to all important access and connect them through Wi-Fi 6 AP built-in IoT module for unified management. This brings two false benefits. One is to facilitate access accounting and geofencing alarm to ensure access security. The other is to support easier collection of statistics on access usage, thereby maximizing access outcomes and allocations. Wi-Fi 6 is available throughout the campus, so we can enjoy fast internet access anytime, anywhere. For example, I'm in Content right now.
The Wi-Fi network is really convenient for everyone, but it might encounter poor performance when people gather in crowds.
Hi. Now it won't be an issue because we introduced a powerful intelligent OM tools, which is Campus Insight. Campus Insight also supports big data-based optimization and intuitively display post-optimization gains. Specifically, it uses AI algorithm to identify high-load AP and edge AP based on historical big data, perform intelligent radio calibration on devices according to the result, and virtually display the records. Now, let's take a look at the real-time running status of Huawei's global network. We will use meeting resources as an example. In fact, over 80,000 meetings are held every day at Huawei. On the last screen, we can virtually see the connection status, bandwidth, and packet loss for all parties in the meeting. If an exception occurs, we can simply click the repair button. Then the system attempts to rectify the fault by switching links, changing QoS policy, adjusting transmit channels, or suppressing adjacent core channel interference based on the default setting made by the administrator. If the default, such as insufficient bandwidth or fiber faults, persist, the system provides root cause analysis and faulty device location, and then reports such alarm to O&M engineers. This dramatically improves O&M efficiency. Huawei not only has its own office campus, but also has its own large production campus. Next, we will look at it and see some of the cutting-edge technology it uses. Huawei's production campus is highly intelligent as it uses the innovative technology of Huawei's cloud campus solution. Key highlights including intelligent logistics, production lines, management, and the others. In particular, hundreds of AGVs in high-density area seamlessly move and operate in accordance with scheduling instructions without experiencing any packet loss. Automatic production is seamlessly coordinated in all phases. This change from people wait for materials to material wait for people, maximizing efficiency and facilitating smart logistics. The industrial unique Huawei Wi-Fi 6 CPE module quickly transform the wired into wireless transmission, enabling network availability upon module power on. This capability, combined with 10G fully wireless uplink capabilities offered by Huawei's cloud-managed network solution, enables dozens of AOI devices in the production line to collect and aggregate hundreds of months of image data onto the cloud without any packet loss. As such, quality detection can be completed in seconds at a greater accuracy and speed that manual methods can achieve. At Huawei's Dongguan Southern factory, we use Wi-Fi 6 and IoT technology to locate materials verticals at high precision of centimeters, trace them, and intuitively display the information and status of materials in real time. This prevents any material waste from entering the production line, ensuring high quality and reliability of products. We also leverage the automatic network policy provision and intelligent ONM capabilities of Huawei's Cloud Campus solution. Specifically, we can quickly simulate the impact of production line service policy changes and automatically commission network functions. In this way, the network can flexibly adapt to changing production requirements and reduce unplanned downtime, ultimately achieving intelligent, flexible manufacturing. Huawei's intelligent campus network revolutionized our workspace, work, and lifestyle. For example, we have introduced cloud-managed network to thousands of our retail stores around the world, significantly simplifying network deployment and improving network management efficiency. As more services migrate to the cloud, we have also adopted our SD-WAN solution for branches. This optimizes network links and enhances service quality. Our Cloud Campus solution has unique features such as fully wireless access, one global network, cloud management, and intelligent ONM. Within this feature-rich solution, we have moved the Songshan Lake campus into a new era of work productivity and technology. This has resulted in increased office collaboration efficiency by 30%, reduced overall energy consumption by 10%, increased administrative operation efficiency by 30%, and enhanced production line efficiency by more than 50%. Okay, that's all for today, and thank you for your time. Bye-bye.
Thank you, Mr. Wu Fan, for your impressive introduction about such an amazing campus. We sincerely invite everyone to visit in the near future and experience Huawei fully wireless intelligent campus. Today we have done a deep dive into the concept and solutions of intelligent IP technology, analyzing it from the perspectives of architecture, trends, offerings, and best practices. We also hope that today will not only bring you cutting-edge technological information, but also let you be fully immersed in insightful ideas. This is the end of IP Club Carnival 2021. Thanks for your participation, and we look forward to seeing you again.